Okay guys, welcome to the 3D printing unit. We're going to start this unit while we're all remote, and then hopefully we'll be able to finish it when we get all back together with some printing. So the way this is going to work, we're going to go through the notes today. Hopefully you've printed out the intro packet that was listed next to this video. If you haven't, please go print that out first, or at least have it open on something else so you can see it. There are some notes you need to take through this video, and it would be helpful if you have that as we go. So if not, go ahead and pause and take care of that. Otherwise, here we go. The history of 3D printing. 3D printing became a reality in the late 80s as a method of what's called additive manufacturing. 3D printing works by adding material to create the desired object. Traditional manufacturing uses what's called a subtractive manufacturing, and that's where you start with a block of raw material and you chew away what you don't want. Think like a wooden canoe, a tree canoe, a birch bark canoe. You start with the tree and you carve away everything that isn't a canoe and you're left with a canoe. That would be subtractive manufacturing. Additive manufacturing would be laying down strips of wood on top of each other until you end up with a canoe. It's whether you're subtracting material or adding it. Some of the pros of additive manufacturing are that it does not cause as much waste as subtractive manufacturing does, because with subtractive manufacturing, all that material you're chewing away often has to become waste. We'll talk about more pros and cons as we go, but that's kind of the big one that sets it apart. There are lots of types of 3D printing, and there are three that are by far the most popular. So those are the three we're going to talk about today. There is SLA, which stands for stereolithography apparatus. There is SLS, which stands for selective laser sintering. And there is FDM, which stands for fused deposition modeling. So we're going to go through each of those three types and then talk about which of the three types we have. So stereolithography was the first type developed. It's incredibly expensive then, and it's still very expensive now. The first machines were well over $100,000. Modern ones, if you wanted to go buy one to take home, you'd be spending probably at least $1,000. SLA printers work by heating the raw material to a liquid and then using ultraviolet lasers to cure that liquid into plastic. So you create a pool or a bed of this melted plastic, I guess for lack of a better term. And then there's a laser mounted on an XY axis, so it can go left and right and forward and backward. And it is an ultraviolet laser that cures that plastic. When the plastic hits the laser, or the laser hits the plastic, it turns solid. And then as each layer is created, because it just makes a very thin layer when it does that, then the laser axis moves up, bringing the plastic with it, and it repeats the process. The benefits of stereolithography are the speed and the high quality. This method is quicker than some of the other 3D printing methods, and it creates high quality prints. What that means is you don't see any lines on the print, you don't see any layer lines. You don't have to do as much finishing. You might not have to sand as much or repair as many defects as you might in other methods. Some of the downsides, the cons, it's still very expensive, well over $1,000 usually. And many prints will need to cure in an ultraviolet oven. So after they come out of the printer, they're solid, but they need more time to cure. So they need to be put into another machine that kind of bakes them in ultraviolet light to finish the process. So it can be a little slower in that sense. The next type that we're going to talk about is SLS, selective laser sintering. It's where we use high-powered CO2 lasers, carbon dioxide lasers, and they kind of meld granular particulates together. So think like a bed of sand, but a very, very fine sand. We use a carbon dioxide layer to kind of weld those tiny particles together, creating a larger solid object. They can use a lot of different powdered materials, such as metals, nylon, ceramic, or some can even use glass. So the process is very similar to stereolithography. Lasers are used to cure one layer at a time, and then the object is raised out of the bed. Another benefit of SLS is that the support material isn't always needed. So we'll talk more about more support material, but think about if you have like a doorway. Let's say you're printing a house and you have a doorway. That top bar of the doorway, the header, is very difficult to print when using 3D printing because you have to lay material down over thin air, essentially. And with SLS, you don't need to do that because you're solidifying that top layer, but there's a whole bunch of sandy or powdered material underneath it supporting it, so that the unused material kind of acts as your support material, which saves on a lot of waste. So benefits, again, very fast, high quality polished parts. It's some of the best quality in terms of what you can get. And the biggest benefit is probably the wide variety of materials. The fact that you can use plastic or ceramic or glass or nylon or metal is a really big deal. Um, One of the biggest downsides of 3D printing is that often the parts are plastic, and that's not necessarily going to be adequate for whatever the final purpose of that part is. Some of the downsides, cost can be prohibitive. I mean, if you thought SLA was expensive, SLS printers can easily run over $5,000 just for one that we might have like here in a classroom. I mean, they're expensive. It's messy. All that powdered stuff gets everywhere. It's not always that good for you. The parts can be brittle when they're done. They're easy to shatter potentially, depending on the process used, and it creates a lot of waste. Some of that powdered material can't be reused at times, and I honestly don't know that much about when it can and can't be used, but I just know that a lot of times it has to be thrown away at the end of a print. Yeah, so that's SLS printing. The third type, and the type that we're going to be most interested in, is FDM, Fused Deposition Modeling. It's the most approachable method in the sense that it's the most attainable. It's the cheapest. There are the most of them out there, and it's by far the most popular. So anytime, if you've been picturing a 3D printer, you've probably been picturing an FDM printer. The one that's in my classroom is an FDM printer. They work by melting plastic filament and extruding it in thin layers. So basically we have this big spool of plastic spaghetti. The nozzle or the extruder gets very, very hot, and then it pushes the raw plastic, that plastic spaghetti, through a much smaller needle. That's what the extrusion is it pushes it through, making it much smaller diameter while it's still melted, and putting it down in thin layers. And then it cures or dries very quickly as it cools, so it doesn't stay liquid for more than a couple seconds. The extruder moves in the X and Y axis. So the X axis is going to be the side to side. So on our printer, if you can picture, let's go back to the front here real quick. This is the same printer we have. So this is the X axis, moving side to side. This is the extruder right here. There's some other parts there we'll talk about, but it slides back and forth on these two rails being pulled by a motor. This top black box is a motor, and it's hard to see in this picture, but there's a rubber belt going back and forth that pulls the extruder along this x-axis. The y-axis is actually this print bed. It moves back and forth on rails also. So the extruder can only move left and right, and then the bed moves forward and backward, which gives us the x and y axes. The z-axis is these vertical bars, and the entire x-axis slides up and down the vertical bars as it's printing. So we put down one layer, so if you look at this dragon, that would be the tips of its fingernails probably, and maybe the outline of its belly back there. And then the x-axis picks up like 2 millimeters, very small amount. And when it puts another layer on top of the layer it just created, and it just keeps doing that. So the extruder goes back and forth, the print bed goes front to back, and then after it lays down a layer, the entire x-axis moves up a little and continues printing. The cheapest FDM printers you could purchase for under $200. I think they sell a knockoff version of the one we have at Walmart for about $150, but better quality machines can cost well over $1,000. The Prusa printer that we have is, from all the research I've done, an excellent middle ground in terms of price point, not being incredibly expensive, but it packs a lot of features into a printer for the price we pay. I mean, this printer is right around $1,000, and it prints with as much quality or better quality as some printers that cost twice as much, and it has more features than some printers that cost twice as much. The downside, you have to build it yourself, which I enjoyed doing, but many people would not. And the other downside is that it doesn't have as many user-friendly features. There's no touch screen. You can't plug in a USB stick. You have to make do with some other downsides, but in terms of the quality of printing, it's up there with the best. So here it is again. The Prusa i3 Mark III S is the printer we have. It was invented by Joseph Prusa as part of what's called the RepRap movement. We'll come back to that in a second. It's manufactured in Prague in the Czech Republic. The i3 is the model, so this type of 3D printer is called the i3. The Mark III is his third revision of that model, so this is kind of like 3.0 of this type of printer. And then the S is just meaning the newest version of that third revision. It just gives it's kind of like the model number. It tells you how updated it is and how modern it is. The Mark IIs, the one that came right before this, is the best-selling 3D printer of all time. They have sold an incredible number of these all over the world to professionals, to engineering firms, to be used in manufacturing, all the way down to just families who want to play with it, tons in schools. It's very, very common 3D printer because of what it offers. So let's go back to this RepRap movement for a second. The RepRap movement is something that suggested that a 3D printer should be able to print itself. People want to create a machine that can replicate itself, kind of like the idea of free energy. It seems kind of cool to have this machine that could recreate another machine just like it. Obviously, you can't print the whole thing. You can't print the motors. You can't print the hardware for the extruder. You're not going to print all the metal parts. But every piece of plastic on our printer, everything that you see is orange, and then there's quite a bit more black plastic too, actually, was all 3D printed. This is an open source design, which means that if you got online, you could download the files for all of this and you could print it yourself. You would have to go find the metal pieces yourself. You'd have to find the power supply and all the cords. You'd have to find the motors and the fans and the extruder and the screen and all that kind of stuff. That would obviously not be included. But they put their designs out there for free in the interest of bettering the community and making 3D printing even better. That's how Joseph Prusa got started. He found a design. He's like, well, this is terrible. I can make this better. So he and his brother worked on one and made it better, the i3. They took an i2 and made it into an i3. And then they just put the plans back out there, and people wanted it so badly they were offering to pay them to make it. And so they were making a few at their house and shipping them to people and making money doing that. And they realized they were getting more and more orders from people even though it was free to build. So they decided to make a business out of this, and kind of the rest is history. They have a huge company now that makes a lot of 3D printers. This is the tour of the Prusa factory. I have linked to this video also. It's video number 2. I would like you to pause this and go watch at least the first 5 minutes of this video. If you are interested and you want to watch the whole tour, that's excellent. But at least watch past the part where they're in this room that you're seeing right now. When you get to the filament manufacturing, you can stop if you'd like, but I'd like you to watch all the way up through the tour of the plant itself. And the reason why is you see how many of those printers they have on the shelves. This is where they make these printers. So the printer we have, all the plastic parts were printed on a printer just like the one we have, but in this factory. So it's kind of cool. So go ahead and pause this and go watch that video and then come back. Okay. Hopefully you watched that last video, the Prusa tour. If you found that interesting, I've also linked the optional video 3, which is the road to 100,000 printers, and it kind of tells the story of the Prusa company and where they came from. I thought it was very interesting, so that's out there for you to watch if you find this stuff interesting. If you don't have to watch it. There's one other short video I want you to watch some of, and it's a time lapse of prints. It's fun to watch. It's cool to see how this works, but there's a few things I want you to notice as you go through this. I want you to notice how it layers. You'll see it slowly grow vertically through layers. I want you to notice the infill. It's a vocab word coming up, but I'll give you a hint. It's this stuff in here. You'll see quickly that these 3D prints are not solid plastic. You're usually very far from that. And I think in a couple of the prints you can see a clock in the background. And so I think this is that video. If you see a clock in the background, just notice how long this takes. It's not a quick process to make an object, but it's much faster than it would be to make this object using some other method of manufacturing. So go ahead and pause this one again and go back and watch video 3, which is the time lapse. You don't have to watch the whole thing again if it's not all that interesting, but I want you to watch at least 2 minutes of that time-lapse video. So go ahead and do that now, please. Okay, hopefully you got a good chance to see the layering, the infill, maybe the print time, and just got to see some cool videos of stuff being printed. I think it's fascinating, and I hope some of you do also. So, like we've talked about, 3D printing is a slow process. It can take many hours to create one thing. However, it's very fast considering other manufacturing techniques. So, if you design a dragon or a tiger and you're going to print it, it might take 8 to 10 hours to print out that dragon. That being said, that seems like it takes forever. That's a full day, right? I mean, that's more than a school day. But if you think about it, how long would it take you to make that dragon using some other method? Much, much longer, right? Especially in terms of the education you'd have to get before being able to use that equipment. The education you need to run a 3D printer can be taught to yourself over a weekend. The other methods you might use to make that dragon would probably include welding or machining, and those things are going to take you much longer to learn. So although it's not instantaneous by any means, it is much, much faster to create things using 3D printing. The benefit for that is for prototyping. If you invent a new thing and you want to see it in your hands, you've got a design, maybe you've modeled it in the computer, and now you just want to hold one, 3D printing is the fastest way to make one of those. It's not the fastest way to make plastic products. Injection molding would be much faster to make plastic products. But you have to make tools to do the injection molding first. You have to make the molds, assemble the machine, and get everything calibrated. That's not true for a 3D printer. So its biggest benefit in industry is probably prototyping, showing a first round of something. Then you can go, oh yeah, this needs to be bigger, this isn't going to fit, whatever. And you can make a new one. So you could run through 2 or 3 versions in a day. Whereas with other manufacturing methods, you might be working on them for months to try and get some prototypes. Some things can be adjusted to improve the speed if you really just want to go fast. Things such as the infill percentage, layer lines, the number of layers, brim, all these things can be adjusted, but they all have trade-offs. If you sacrifice things for speed, you're losing quality, or you're losing stability, or you're losing strength. So there are things that can be done to speed the printer up. But it does come at a cost, and that's always something that has to be weighed. So hopefully that gives you a little bit of an intro to 3D printing. You have a little bit of an assignment tonight, and then we're going to pick back up with some of the design aspects of 3D printing tomorrow. So tonight, you need to research and define a list of terms so that we can speak the language of 3D printing. It's important that we have correct terminology in everything we learn, whether it's math, driver's ed, or 3D printing. It's important to understand the vocab and to be using correct terminology. So on that note packet I asked you to have printed out, you'll see a big long list of vocab terms kind of organized by section or by type. I want you to look all those up and write down definitions for those before tomorrow. I recognize that you won't be turning this in prior to when we return to school. And you might be tempted just to wait and do it later, but I promise you the rest of this will be easier if you have an understanding of these terms. So please get that done tonight. Just like everything else we've worked on, keep it safe. You will turn it in when we return to school. And then tomorrow we're going to start designing things. So thank you for watching this. Again, if you're interested in that video of the Prusa company, that is video number 4. It's not required, but if you found it interesting, you might want to watch that while you do some research. Thanks, guys. We'll talk to you tomorrow.